in the fourth and final segment of the introductory material, this is actually where the physics course really begins. And we're talking about sig figs, significant figures. So what's the goal today? I want you to be able to determine significant figures, which is a challenge when presented with a value, or determine how many significant figures to use when performing calculations. So if you're taking the 3U chemistry, you're going to be seeing very similar material in this particular video. So you may have already covered this. So in both physics and chemistry, there's a great emphasis or importance with significant figures. So it's definitely, this is a tricky concept. Grade 11, I'm a lot more forgiving than grade 12 when we talk about sig figs, but the rules do come easier and easier as we go. So significant figures is how accurate are we measuring something? And I always say, if in doubt, convert back to scientific notation because that's helpful. So let's go through this and we'll talk about each one individually, and then you'll get some chances to go through and try some of the homework. So the first one, 2300. What are the significant figures, or how accurately are we measuring this? There's actually two solutions here. It could be 4 significant figures, meaning that each one is significant, or it could be 2. And the reason for that is because the decimal is not placed here, but there's also the potential assumption that the decimal is here. So in this case, there are a possibility of 4 or 2 significant figures. So what does that mean? It means in the case of the 4, that we can measure right down to the ones column. So each digit is significant. However, it could also mean that we can only measure to the hundreds column. So that the scale only measures to the nearest 100. So it's only 2 digits of significance. So it really depends on, that one's a little bit on the ambiguous side. So there are cases where it's an either or situation. For the second example, I see that there's a decimal and I see that 2 zeros have followed that decimal. What that tells me is that those digits could potentially be part of our measurement. So in fact here we will have 4 significant figures. Okay, so each of these is an indicator of how many significant figures we will have. The reason again that there's 4 is because the decimal place is placed absolute, or we see it there, and 2 zeros have intentionally been placed in, so those would be considered inside the sig figs. For the third one, when it's a decimal like this, there's always, this is where I get confused myself. My friend always tells me, if you're not sure, convert it to scientific notation. Okay, so if we're to convert this to scientific notation, the decimal would come back here to the 3. So I'd end up with 3 decimal. Those zeros were placed for a reason. Okay, if it was just 0.003, we wouldn't put those zeros in, but those zeros are there for a reason. So I add those zeros in, multiply by 10 to the exponent negative 3, and now it becomes a lot more clear. There are a total of 3 significant figures for this particular number. Okay, so if in doubt, always convert back to scientific notation. Okay, if the zeros after the decimal in scientific notation are placed there, they're there for a reason. Which means the last example is quite straightforward or simple. It's in scientific notation. Those 3 digits are there for a reason, so therefore we have 3 sig figs. So I have a worksheet for you to go through. Try a couple of these. They will be frustrating in some cases. Some people seem to have a knack for it and jump all over that. So anyhow, those are some of the governing rules. But if in doubt, use scientific notation. So if in doubt, use scientific notation. Okay, and that'll help you out with that. Adding and subtracting, here's the written definition. So the result, or your answer, when numbers are being added or subtracted, should have the same number of decimals. Okay, so there's the key there. Same number of decimals as the least precise number. So I have 2 examples here for us to go through. First of all, I want to identify the least precise. And that's the one that has, if you think of it in terms of a scale, the one that's the poorest measure. And in this case, this scale only goes to the 10th column. So that means we're only going to have 1 decimal in our answer or our solution. Okay, so you just plug this into the calculator as per normal. Whoops, that's the calculator. So clear that up. So I got the 2458.023 plus 340.2 plus 2.57 equals, so we get 2800.793, 2800 decimal 7, I can't even remember that goldfish memory, 793. So what's the final answer? We can only go to one decimal place because that was our least accurate. So our final answer would be 2800 decimal 8, and that's as accurate as we can go, even though there's more decimals. Okay, similar with subtracting, just another example here. This one, even though it was an even 0.5, it indicates that it could have gone to the next column. So this one, in fact, would have 2 decimals of accuracy. So using the calculator for that one, we got subtraction. So 2.5, oops, that's not 55, 5565 minus 0.5 minus 0.252. You do that calculation, and we end up with an answer of 1.8045. 8045. Going to 2 decimal places, that would mean that my final answer is 1.80, and the 0 is important to include in there. It shows how accurate we are with our final solution. Okay, so there's adding and subtracting. Moving on to the multiplying and dividing. The result, or our answer when numbers are multiplied or divided, has the same number of sig figs, so not the same number of decimals, the number of sig figs as the least accurate. Okay, so a little bit more challenging. So you got to figure out number of sig figs. So that's why it's important to be able to do significant figures. So maybe we'll do both here. If in terms of significant figures, we see that the first number here has a lot of significant figures. It goes right out. However, the second one is only, there's no zeros following the 5. So that means we only have 3 sig figs here. So that our answer has to be 3 sig figs. Over here, on the second example, we'll do significant figures to start. I've got scientific notation, which is awesome because it makes life a lot easier. This one has 3, this one has 2. So our final answer can only have 2 significant figures. All right. So now we go ahead and we do the multiplication to get one answer, and then we kind of clean it up in the end. So we have 238.54935. Multiply that by 4.25, and the answer is that large mass there. So 1013 decimal, and we'll go 83474. 83478. 83478. Okay, so significant figures here. We can only have 3 significant figures. So 3 significant figures means that when we look at this, or you convert it to scientific notation, maybe I'll do that as a first step here. Scientific notation would be 1.0138347 times 10 to the 3. So the first 3 significant figures is the 1.01. So our final answer is going to be 1010. Okay, for our final answer, or you leave it in scientific notation as well. But there's your sig fig. So it's based on the least accurate in terms of the sig figs. So the other one, just finishing it up, finish off the note here. The 5.95 exponent 9. And we'll do the divide by 2.5 exponent 4. And we end up with an answer of 238,000. 238,000. All right, we want 2 sig figs, so sometimes it's just as easy to go to that scientific notation if you're not sure. So 2.38 times 10 to the 1, 2, 3, 5, the 5th. 2 sig figs would only be the first 2 digits here. So that means our answer would be 2.4 times 10 to the 5th, or simply 240,000. 2, 3. Okay, so there we go with our sig figs. So there's a couple of adding, subtracting, multiplying, dividing questions for you to look at as well. Finally, a couple of things. I'm not going to go through all of them. I'm going to emphasize for beginning physics students what we're going to be looking at. You're going to be doing a lot of labs. You're going to be doing some oral assessments for me, which is part of the labs, where you're going to just tell me what you think the solution is, or give me a quick write-up. So definitions. When it comes to me assessing you, I'm looking for you using the proper terminology. So it's very important that you learn the definitions so you can use the terminology carefully in the course. Make sure you read the question carefully and answer what's being asked. Okay. You're teamed up, working in groups. Use those people in your group to help you out. Just make sure, be careful a little bit later on here. Some courses you can kind of talk your way through, a little bit more challenging in physics, so it's important not to just copy the answers from your neighbor. You got to understand them. This one's huge. Diagrams. Pretty much the majority of questions in this course you can draw a diagram for, so it is very important that you do sketch out the problem. It does help you with your answer. Make sure that you're using SI. So I'm kind of paraphrasing here or reducing it down. There's only a couple things that are very, very important here. Make sure that a lot of the questions, the application questions, are decoding. So it's a good idea to list the quantities that you're given or what you're looking for. It just seems to help with that, picking the correct equation. So it is going to be decoding, and I'll talk about that as we move through this particular course. Make sure the formulas are readily available. You know that you get a study sheet or a cheat sheet for tests, so please make sure you kind of keep a running tally so you don't have to go looking for information. It's there for you. So I always recommend every time you come across a formula or a definition that you want to know, put it on the cheat sheet. You can clean it up later. Make sure you try to associate problem with the concept in class. So anytime you come across something new, it is related to something we've talked about in class at some point. So try to make that connection, looking through your notes or talking with your neighbor. If you're stuck, all my examples relate back to questions that are in the homework. So please flip through the notes. But like I said, you're working in teams, you're working as a collaborative group here, and then I'm there as a fallback. I'm going to skip over 9, and the last statement here, don't expect all problems to be easy, okay? If all the problems in physics were easy, then people would say physics is easy. Actual concepts of physics, I think, are on par with other courses. It's the math that makes people shy away from physics or classify it as being very, very hard. So make sure you discuss it in a small group. You're in a collaborative group for a reason. I want you to talk it through. I want you to come up with your own conclusion instead of me just feeding you answers and you just kind of memorizing what I've told you, okay? And finally, especially with labs, okay, I'm looking for an educated guess. The answer, I don't know, just tells me that you're being lazy and you don't want to think. Okay? Educated guess. I want you to take a guess. You may not know the correct answer, but taking a stab speaks a lot more to your ability than sitting there shrugging your shoulders. You got to be, in this course, you can't be afraid to be wrong, okay? If you knew everything, you wouldn't be in this course, so keep that in mind. All right, we'll talk about some of the stuff as we move through, give you a hand with some of those significant figures, worksheets, and you're working on hopefully the vectors assignment or finishing that up so that we can move into the next stage here. So anyway, any questions, please make sure you ask them in class.